Hey everyone, I am Pragati from the Robotics Club of VIT, and this is the first video of the series Basic Electrical and Electronics. So, to begin with, mostly all starting projects require an essential component called a microcontroller. Now, what is that? So, let me start by explaining what that is. A microcontroller is a computer present on a single integrated circuit, which basically means a large number of transistors present on a single chip. And this integrated circuit is dedicated to perform one single task. So it's task specific or has a specific application like to control the functions of embedded systems. Now, embedded systems are, as the name suggests, embedded in a larger system. Basically means it's a smaller system which performs one single task, and a large number of these specific tasks performed is going to make your larger systems. Now, these are examples of larger systems that you can see, like home appliances, laptops, PCs, automobiles, and all that. So, as you might have guessed, there is something in common in all of these devices, and the fact that it employs a microcontroller means that microcontrollers are basically employed in devices that need a degree of control to be applied by the user, which means that any kind of device which would require human assistance or which would require a user is going to contain a microcontroller. And the kind of devices that it's employed in can store, measure, display information, calculate, and do all those stuff. So based on its application, you're going to have different kinds of microcontrollers. Like in the market, you have those with different word lengths, like 4-bit, 8-bit, 64-bit, 128-bit. Initial projects are going to use Arduino UNO board, which contain an 8-bit microcontroller. Now, to know how exactly a microcontroller works, we would also need to know the internals of a microcontroller. So there are mainly three things in a microcontroller: the memory, programmable input-output peripherals, and a processor. So let me start by talking about the memory. The memory is basically the it works like a microprocessor. And what's a microprocessor? It's the CPU of a computer. So it does the functions like data storage, interaction with input output devices, basically connects everything together so that a microprocessor, or rather a computer, can perform its functions. So a microcontroller's memory is capable of doing all that, but the only difference between um, the two, that's microcontroller and microprocessor, is that a microprocessor was developed to perform a wide range of tasks, while a microcontroller is task specific. So there are more differences as well, like a microcontroller consumes lower power as compared to a microprocessor. The reason being that a microprocessor has a really complicated circuit. So accordingly, it does consume a lot of power. It also has a higher speed and a higher cost given its perks, and microcontroller has a lower speed and lower cost. Also, a microprocessor has a flexible memory while a microcontroller is going to have a fixed one. So just to give you another clear idea of what a microcontroller and microprocessor is, just this part, that's the CPU, is going to be your microprocessor, while your microcontroller is going to be all of that together, like all of this together. Now, your next part, that is the input output peripherals. What I basically mean by it are ports. So they are employed to interface or drive different appliances like, say, LEDs or LCDs and other stuff. So different microcontrollers are going to have different schematics as to how or where the input output peripherals lie. Now, the last and final and the most important part is your processor. That is the brain of the microcontroller. So, using it, the entire microcontroller is connected with its components in a single system, and instructions are fetched by the memory and decoded by this processor. Now, this thing is neither a microcontroller or a microprocessor. Arduino is just a development board, and it contains a microcontroller, that is the 8-bit AVR, which I mentioned before. There are three main ways you can actually power an Arduino board. One is the USB cable, other is the barrel jack, and you can also connect it using jumper wires to a source using the VIN pin right here. Now, these are going to be for output. The 3.3 volt and the 5 volt are output voltages that can be provided by the Arduino, and these are ground. So for you to know, an Arduino works on a voltage range of 5 to 20 volts. Above it, it's gonna burn. And it provides an output voltage of 0 to 5 volts. So as you can see, these are the voltages which can be altered by series and parallel connections or based on how you connect it to your devices. Now, obviously, like because of fluctuations, you might get a value which is slightly greater than 20 volts. So for that, we have a voltage regulator which has a MOSFET in it, uses MOSFET basically, and you have these PCBs and um, these cylinders as capacitors. Again, this is just for you to know. But the main thing that you'll have to care about when you make projects is the pins. So these on this side are the analog pins, while these are the digital pins. And those with the tilt sign are your PWM pins. So a PWM pin basically converts digital signals to analog, but that actually is we comprehending it as analog signals. More about PWM pins, you'll find it in later videos. Now you have these 6 analog pins, which can also act as digital pins. And these digital pins and analog pins have one specific difference in them. These work at a lower resistance and therefore can produce higher currents compared to these at the same voltage, that's 5 volt. Now, these two that you see over here, the receiver and the transmitter port, are those that are going to be connected to the transmitter and receiver port of the sensor or any kind of device that has those ports in it. Now, you just have to be careful with the fact that you have to connect them the other way around. So, the receiver of the Arduino UNO board is going to get connected to the transmitter pin of the sensor or device, and the receiver pin of that device is going to get connected to the transmitter pin of the board. Now, the red button that you see here is your reset button. So basically, it compiles the entire code again and makes the Arduino UNO board, start its processing again. Like basically, it resets it. So that's it about the Arduino UNO board. Now, to code in an Arduino UNO board, you need to use an Arduino IDE, and that's what we're going to see now. You could head over to the official website for the Arduino IDE and download this free software, which on installation on your PC, be it Mac or Windows or Linux, will open a window which looks like this. Now, all of the projects are called sketches, and to open a new sketch, you just go to File and New. Once you're done with your coding, you'll have to verify or compile it and then upload it to your Arduino board. So, to just show you, I have an example code over here. I'm compiling it right now. After compiling the sketch, I'll have to upload it. I go to Tools, I select my board as Arduino UNO because that's what's connected right now, and my port as COM5 for Arduino UNO. Okay, and then after that, I upload it. Once that is uploaded, now because this code is using a serial monitor, I could open it from the top right corner right here, and the serial monitor shows the output. So notice that you could adjust the baud rate, and that baud rate was set over here when we had mentioned serial.begin. Okay, so that's it for the Arduino IDE. Now, I mentioned the term serial over there, serial monitor. So what exactly does serial mean? Now, to understand that, we need to understand how communication between two devices occur. So communication between two machines would require a transfer of signal from an output to an input. So there obviously needs to be a sender and receiver of the signal for the complete communication process to take place. Now, serial and parallel communications are both ways of transferring data over networks. And both of these systems have a unique way of operating, where the difference basically lies in the fact that the method of relaying those signals and the level of connectivity that they would require is going to be different. So, in serial communication, what happens is data bit flows from one device to another in a bitwise manner, which means that one bit flows at one clock pulse. So, like here, 8 bits are transferred at a time, having a start and a stop bit. Notice you just have one transmitter and one receiver in this case. But in case of parallel, you have more than one transmitters and more than one receivers. Now, to explain that further, in parallel transmission, you have all bits, or like many bits actually, not all. Those bits are basically divided into parts, and those are flown together simultaneously from one device to another. So it's kind of obvious why parallel transmission is faster than serial. But the fact that these are transferred not in a sequence but parallelly makes it more prone to distortions. So, like the data can end up becoming distorted in the receiving side. So, therefore, parallel interface or parallel communication is usually preferred for shorter distances as compared to serial. And that explains serial and parallel transmissions. So, with this, I would like to end this video. In the upcoming videos, you'll learn a lot about different components that will complement a circuit, like a variety of sensors. You'll also learn how to code in the Arduino IDE. So, for getting the latest updates on our videos, do share, subscribe, and like our channel. And that's it for this video then. Alright then, thanks for watching.